Let's go. All right, folks. How are we doing? It's your boy Joe. Happy what day is today? Today is Tuesday. Tuesday, I say. Welcome to Tuesday, everybody. It's Joe. It's your boy. Coming in 50 different colors across the nations. All right, everybody. Let's finish part 5. Woo! Man, has this been just a struggle to get through part 5. I don't know what it's been. Whatever. You know what? I say the more time we spend on a chapter, the better we're gonna learn it. So, yeah, but I really want to make a hard push, to make it through this is part 5, yeah. So, just want to give everybody a quick shout out. Thank you for the last couple follows. Mini Tigra, T Mikes, Mr. T Mikey Mikes. Who else I got? I got S Blue 1977. I got me some Itch a Chick Fever. I got me some Stanley Peace and Love. And then my boy Joey the Dino. Just big shout out to all you guys. I'm only 10, counting on these fingers, 10 followers away, guys, from hopefully finally becoming an affiliate. So let's make it happen, guys. Let's get me 10 more followers. All right, and then we can finally, if my viewership thing doesn't mess me up, get me over to the finish line for affiliate there. So big shout out to everybody that's been making this happen. This stream's been awesome. I've been having so much fun. I've been stressing out over it though, but it's all good. We're making it happen, Captain. This studying's been going amazing though. I have to tell you though, guys. I guess like I keep on saying, this stream's all about learning and then progressing in the studies and whatnot. So I just wanted to let you guys know that this has been nothing but amazing this whole entire time. Let's continue on. Let's get through part 5. Enough talking. Let's get through it. I'm gonna need more coffee. I got called into work even though I had the last 2 nights off. That's not gonna happen now. I'm working, so woo! Alright. Let's dive right into it with a study. Let me get this switched over to my other monitor. Bloop. Let's launch a quick study, guys. We won't go through with the big one. We'll just go through a smaller one. This one's the better one for me to do this on, man. Bloop. All right. Here you guys can kind of see it. All right. So let's just review the chapters we're actually on right now. Actually, let's keep it the full gamut. I want to see how many we get out of it. Because I need to beat myself up. I need to really beat myself up over these 2 chapters here. Because I was kind of lacking on my well, just because I need to just keep working on this part here. So let's oh, you know what I gotta add? I always forget to add it. And for some reason I always like having it just because I like to see the viewer countage. I like to see how many people are watching. Oh, it's so small. I need to make it bigger. Bloop. Da. Dar. She blows. Dar. Right. That's a good. Alright. Well, hello. Alright. Chapter 15, chapter 16. Very good. Alright. Let's get right into it. All right, referring to the diagram in exhibit, based on the information displayed, what is the cause of the connection interface? What is the cause of the connected interface having a down protocol state? Okay, what do we got? We got serial. Let's look at the what do we got? Serial up, but it's down. Okay, and then it's connected to which serial port was it connected to? Let's take a look. So 0, 1, 1, 0, and 1, 1. All right, 0 and 1, 1. So here's the other one. That's down as well. Oh, they're in different subnets, maybe? Yeah, they're in different subnets. That's why. 10.20.20.2, 10.10.10.1. Yeah, all right. Not configured interface, not configured mismatch subnets. Ah! All right, let's read this. Based on the information displayed, R1's SW interface has a DSC cable connected to it, but the clock rate number command has not been configured on the interface. Let me look at that again. You know what? I didn't even look at that. So it's saying 1 zeros on router 1. All right. Could have sworn it was it knows best. All right. The exhibit shows the output of the show interface brief command on router 1. All interfaces in the exhibit should work under normal conditions and have worked in the past. Which of the following is the most likely condition that would cause the output in the shown exhibit? So we have the serial ports administratively down. Router statistic does not have any problems other than the fact that there has no IP address assigned to it. What's 0, 1? 0, 0 slash 1, 0, 0 slash 1, down. None of them have an IP address assigned to them. The switch port connected to the R1's power interface has been shut down on the switch. Yeah, we don't know. I mean, possibly. That's down. Right, it's 0 slash 1, right? Yeah. All right. The router the router on the other end of our router 1's 0 slash 1 slash 0 interface has been configured to use PPP, but router 1 is still using HDLC. 0 slash 1. Oof, this is some tough ones. All right. The serial link connected to 0 slash 0 slash 0 is having problems inside of its telco network with the telco currently supply. Oh, that's just administratively down. Let's go with that one. Ah! Oh! Man, that was a tough question, guys. Holy guacamole. All right, let's read the explanation. Bus/01 is in the up-down state, which generally refers to layer 2 problems. For the answer that suggests the adjacent switch interface shutdown, if that were the case, R1 would not see any electrical signals on the cable, so R1 would instead place the interface in the down state, implying a physical layer problem. So layer 1 problem. All right, so serial/0/0/0 has a shutdown command configured, so there is no way to know whether the actual link has any layer 1, 2, 3 problems. Serial 0/0/1 does not have an IP address assigned, but the lack of an IP address would not cause the down status. So some other problems probably related to layer 1 exist. For serial 0/1/0, which is in the up-down state, the state implies a layer 2 issue, so the misconfiguration of layer 2 protocol would be one reason for the problem. So router on the other end of 0 on the serial interface 0/1/0 has been configured with to use point-to-point, but router 1 still has the default HDLC. That was a tough question, guys. Holy moly. That was the only information I had to work with. That one was tough. Holy guacamole. Still don't understand it, but I guess that's why we're doing this review right now. Which command would enter an IP address on the router's interface? IP address, and so the IP address command, the obvious IP address, and then the mask. So there's no mask command, subnet command, or nothing like that. And this would not work. So I know that one. All right. Of the Cisco iOS commands that are typically used to view the interface IP address information, which one shows only the address but not the mask information configured on the interface? On the iOS command, that are typically used to view interface information, interface IP information, which of the show only addresses but not the mask information? Interface brief or show protocols? Show IP interface brief. So show protocols would be the other one that will show you all the information. UI troubleshooting connectivity issues with a router. You type the command show IP interface brief. You notice that the status is administratively down and the protocol is down. All right, so it's administratively down and the protocol is down. Okay. What is the meaning of this information? The interface is not shut down, but the layer 1 and layer 2 interface is a function. Layer 2 has a problem. The interface has a shutdown command configured on it. So when something is administratively down, then somebody's actually commanded it to be down. Okay. All right. Refer to the diagram. Which cable types is used in the? Refer to the diagram. Which cable type is used in the reference location? So, what do we got? We got coaxial. We got coaxial because this would be the serial to the It's like what's CCSL? That's like the cable. Man, I just talked about this. These are like the CADOM. Oh, let me look this up so I can get you guys the actual terminology. Hopefully, it's in the back of the book. I can find it real quick. Hopefully. I'd be upset if it isn't. Oh, there it is. Yeah. So, CSU and DSU, channel service unit and data service unit. So, channel service unit and data service unit, a device that understands the layer 1 detail of a serial link installed by the telco and how to use serial cable to communicate with the networking equipment such as a router. So this would be a type of like a device that the serial link gets plugged into. This would be installed by the telco company or the ISP or whatever have you. So, but this would be the UTP cable, coaxial cable. Ooh, that's a. Now I'm stuck. Coaxial UDP. Let's go with UTP. Ah. Although modern routers often use, let's read that word again. Channel service units and data service units that are built into the card installed. External. All right, so modern routers have the cable, the channel service units and the data service units built into them. Okay. Into the card. External channel service units and data service units are still installed. In these circumstances, a serial cable is used to connect a router to the channel service unit and the data service unit. All right. Well, remember that. We'll imprint that in our brains for next time. All right. What types of router ports? What types of router ports is commonly used to connect to an external modem so that an engineer can remotely access the device? What types of router ports? So that would be the auxiliary. External modem to access the device. Auxiliary. All right. Refer to the diagram. Which static route statement on R1 would be configured to ensure that all normal device traffic going to 30.30.30.0 network would be routed via the primary path, and all traffic going to server A would be routed via the high priority track. All right. Normal traffic, primary. So what do we got? Primary. So this is the primary right here. This is high priority here. All right. So where do we need to go? So P route. Two, one. Normal traffic. All right, so we need to select two answers. So IP route 30.30.30. 525. This looks pretty good. Yeah, because this is /24. Okay, so this one's looking pretty good. IP route. Wait. Yeah. Right. Yep. High priority route. That's wrong. That's wrong. Okay. All right. So we're gonna go with 1 and 2 here. All right. Very good. Let's keep it moving. All right. Refer to the exhibit and diagram. What static route statement could you add to the central router to ensure that the default route always existed in the routing table regardless of the interface? Okay, let's read that one more time, guys. Which static route statement could you add to the central router to ensure that the default route, always existed in the routing table regardless of the interface, the interface state? The central route. Let's take a look at the exhibit here. All right. Central route. Which static statement could you add to the central router to ensure that the default route always existed on the router? Would that be the instance when you give it the almighty zeros to the default permanent? All right. Yep. I'm gonna go with the almighty 0.0.0.0 with the slash with the mask of 0.0.0. That's the almighty send it in, pretty much just send it route right there. Let's go with it. Boom! That was it. All right. Refer to the exhibit and figure. A branch office is going to use an Ethernet wide area network link as the primary wide area network link, with a serial point-to-point link as a backup. The design uses OSPF over Ethernet wide area link. What command enables you to configure a floating? Remember, so floating. That's when we mess with the actual, what's the name of that? It's like the believability of it. It's the value. All right. Because the static route has a value of, I believe, is it 10 or 1? I think it's 1 by default. OSPF has a default value of 110. All right, what command enables you to configure a floating static route on the branch router to 200.200.200.0 network should the primary link fail? All right, let's see what they're using. Are they using OSPF? What does it even state? All right. So where are we at? Oh, so they are using OSPF. Okay, so remember, an OSPF says a value of 110. Okay. So we can kind of say this one's not going to work. This one's not going to work. Made my pen too big. So let's take a look. Okay. So a branch office is going to be using Ethernet WAN. Where's the branch office? Right here. With a serial point-to-point link as a backup, design Ethernet WAN. Which command enables the floating static command to the branch router at 200.200.0? Let's see where we want to go. Central. Okay. Yo. Site backup. Oh, site backup. And that's off of serial 1. Yeah, okay. So I'm gonna go with this one, right? Because that's the backup, right? 151.50.1 off of serial port 010. Yeah. So we want to use, this is the backup right here, and that's what it's Ethernet WAN link as a backup. Okay. So we're going to use we're going to give it the IP route of 200.200.200, pretty much getting us here. All right. But we're going to be using this as a backup route if our primary route right here fails. This primary route is using OSPF. Okay, so remember it has the value of 110. All right, so we're going to give the floating route the value of 130. So if this fails, then this route will be used. All right, let's go with it. Boom, we did it. Okay. All right, PC1, was just powered on and has not sent any frames into the network. PC1 has a statically configured IP address, and default gateway. PC1 has a statically configured IP address and a default gateway is configured as the FAR01's interface. So the FAR01's, I guess smaller. So FAR01's interface, yeah. All right. PC1 is here. Pings 172.16.0.33. So PC3. It gets a reply. What dynamic ARP entries should appear in the ARP cache of the various devices in the network? Okay. I believe so. PC1 sends a ping and gets a reply. What dynamic? Remember, our address resolution protocol entry should appear in the address resolution protocol cache of the various devices in the network. Routing table. PC4 ARP table. Right, I'm just gonna send it. That's right, because let me just read it. ARP is a local function, and PC1 will ARP for the MAC address of the router's FAR0 interface. And though the process and through the process, the router will learn PC1's MAC. The router will ARP PC3 as well. PC1 will not know the remote PC3's MAC address, and PC3 will not know the remote. All right. So what it's stating is when PC1 here ARPs PC3, it's really though only ARPing the router, okay? So it's only going to learn the router's, is that what it's stating? PC1 learns the MAC, so to learn the interface through the. So it's pretty much stating that the PCs will only learn the ARP information of the interface adjacent to them. So they will learn. So PC1 will learn FAR00s, and PC3 will learn FAR01s, but the PCs won't learn each other's. They won't learn each other's. All right. It's been a tough test, guys. This has been tough. Oh, I got logged out of my server too. All right. In the internetwork here, shown in the diagram, router 1 is in the central site. R1 is the central site router, and R2 is a typical remote office router. The network manager dictates that the remote router should all use the default route to forward packets back to the central site, while the central site routers should use a static route to forward packets to each remote office LAN. As soon as the network manager has correctly implemented a design, you connect to router 1 and router 2 using telnet and issue the show IP route command on each router. Which of the following answers list the output you should see? So, router 1, router 2. The network manager dictates that the remote router should use default should all use default routes to forward packets to the central site, while the central site router should use a static route to forward packets to each remote site. So static. As soon as the network manager has correctly implemented the design, you connect to router 1, router 2, so you are the central site, and typical remote site. Okay. All right. So he's on R1. You connect to R1 and iTunes using tele. So R2 is going to be using the all zeros out the so I should use the default. All right, so this would be the all zeros via that interface, okay? And then R1 would be R1, and then R1 would be okay. Let's send that. Huh. I had a feeling about that, but I didn't see this IP address. You stinker. I mean, I guess I could have assumed. Tell you, this thing's tough sometimes. It really beats you up. All right. Host B issues a ping command to ping host D. Host D's IP address. The ping command succeeds. Which of the following statements is true regarding the ICMP echo request sent by host B? Host B issues the ping request to host D. Which of the following statements is true? All right, so what are we going through? Going through some stuff. The frame holding the packet. The frame holding the packet as it crosses the cable between router 1 and router 2, and switch 3 has host B's MAC address. No, the frame holding the packet across the cable between router 1 and the local has the destination MAC address of the. It might. This one might be right. So we got to select 2. The frame holding the packet as it crossed the cable between switch 1 and router 1 has the destination MAC. The frame holding the packet as it crosses the cable between switch 1 and router 1 has the destination MAC address of router 1. That's kind of true. All right. Frame holding the packet across the cables between switch 2 and switch 1 as the destination MAC address of switch 1. No. The frame holding the packet as it crosses between the cables between switch 3 and hub 1 has the MAC address source of 2. All right. So I want to say, oh, wait. No. So this one's definitely wrong. The serial MAC. Ooh, wait. All right. Actually, that one might be right. So I'm going to go with this one and this one. The second and last one. I think I'm right. The frame holding the packet across. Wait, what did I get wrong? The frame holding the packet across the switch 1 and R1 as the destination map. Oh. Beating me up today. Beating me up. I did awful. I know. Awful, Samuel. Samuel, you did awful. That was rough. That was not nice. That was not nice at all. Holy tough chapter. Holy tough chapter. All right. Maybe we'll review that again at the end of this. All right. So we got into this last night. We did the static routes and all that last night in the Cisco Packet Tracer. Just some stuff to go over. Classful network. Just some terms to go over. So the routing table is organized by classful network. The line is the heading line for classful network. 10.0.0.0 is the default mask class A network /8. Number of subnets, and this is just going over this right here, guys. All right. Number of subnets for the subnet. Number of routes for the subnet of the classful network known to this router for all sources, including local routes. The /32 route that matches each router's interface's IP address. That's just stating that right there. 3, 5 masks. The number of different masks used in all routes known to this router inside the classful network. And then 4, all right, is just a legend code. All right, OSPF, IGRP, and then C connected, S static, L for local. 5 right here. Okay, that's the prefix. The subnet number, the subnet number of this particular route. Prefix length, okay, prefix length /30, okay. We guys know that. 8, the metric for this route, all right, the metric for this route right here. What was 7? Oh, 7. Administrative, that was the word I was looking for. Administrative distance. If a router learns a route from the listed subnets, for the listed subnets, for more than the source of the routing information, the router uses the source of the lowest administrative distance, okay? All right, and then the metric for the route, right there. Next hop router, for packets matching this route, the IP address of the next router to which the packet should be forwarded to. So this is going to 10.2.2.5. Timer for OSPF and EGRP. This is the time since the route was first learned. Okay, so that's all that's showing you right there. All right. Outgoing interfaces for packets matching this route. The interface out which the packet should be forwarded. So just the serial 0-0-0-0-1 serial interface. Okay. So some key terms that we should have learned by now is ARP table, routing table, next hop router, outgoing interface, connected routes, static routes, default routes, host routes, floating static, network routes, administrative distance. Okay. Just some actual command line commands. All right, now let's move into chapter 17. Though I feel as though I feel as though these last two chapters, man, have been really rough. At least on me, they have. All right. Let's dive into chapter 17. Yeah. Let me just do a brief, real quick. VLAN routing. Ooh, I love this one. This is one of my favorite ones, guys, actually. I love VLAN routing. I might know something about this one. Actually, VLAN routing is one of my favorite topics, actually. So this should be a fun one for us to get through, guys. So yeah, we'll dive right into it. Let me get my board set up, that way so we can talk about this in a more. Is there a lot to like stand up and show and demonstrate? I guess this would be more better to just get on packet tracer and stuff like that. Ooh, guys. Give me another day or two for Discord. All right, I promise you. I know I've been talking about it for a while, but just give me another day or two, and I'll have Discord up. And the reason why I say that is because I want to start sharing the packet tracer labs that I build and stuff like that. And again, you guys can download them if you want. You don't have to. I'm not telling you to do it, but I'm gonna start just populating. There'll be a channel that'll populate packet tracer labs. It'll be the labs that, you know, when we're actually working on a particular day, like today. I'll just throw it out after the stream. What I'll do is I'll throw it into the channel, and then you guys can download it if you want, and then take a look at it, play with it, and stuff like that. Same thing would be CML, but you'll have to know how to do all that in CML. And I don't suggest that for any beginners out there attempt to dive into CML and figure that out. That's for more of the well, if you're already doing it, then you're more than welcome. You know what I'm saying? But anybody out there who's new to this stuff, I don't even suggest, just stick with packet tracer. You're better off. So I just gotta log into my server real quick. You guys can still see me, but you can't see what I'm doing. Don't really matter, I guess. Hello. Hello. Come on, my server, man. Come on. Don't fuck up. Oh, 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 oh. I gotta take like the stinking timer off of that thing. That way it never shuts down. Doesn't shut down, it just has a security timer on it, so I just can't. Right. Hello again. Alright. Got an empty router. Alright, we're doing VLAN. We're doing some VLANs today, man. VLANs. So we're gonna be doing a router. The router on a sticky. I love this topology, guys. I love it. I love it so much. It's good. Actually, whoa. Do it like a this. Do it like a this, man. Do it like a this. 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 Do it like a Zoom in. Whoa. No. I'll call you the stick. The stick. Zooming in. Add some gigabit interfaces to you. How many do I need? Just one. Just the one. Nothing more, nothing less. The stick. You are. I'm gonna call you the main vein. No, that wouldn't be too proper. Why is it red? That's weird. Main man. The main man. I like it. He's the main man. Alright, so we just need tres amigos. Uno, dos, tres. Yay! Oh, wait. Quattro. I probably said that wrong. We need 4. 3 PCs and the router. The router. I turn it on. I didn't turn it back on. Sometimes I forget to turn it on. Yeah, you are. Vilan Tan. Hua. You are. Vilan 20. Hua. You, my good friend, will be Vilan. Oh, if I can spell. Vilan Proti. All right. I love the interfaces. It's so horrible. You know what? I'm gonna take those off. I don't want to look at them today. Just gonna make things look ugly. All right, so this is the router. This is going to be the router on a stick. Topology, guys. This is one of my most favorite actually wants to do. So, oh, we got some people. Hello, Stanley. How we doing, my friend? Oh, I'm not too busy. I'm sorry. That's what I get for having the chat on my phone. No, I'm good, my friend. How are you? We're doing some network stuff. You know what? I gotta put it right here. If my phone would come on, phone, cooperate with me. Boop. Boop. No, you don't want to do that, phone. Boop. Mr. Stanley. My phone's being a pain in my butt today, Stanley. Sorry about that, mate. Good to see you, my friend. I probably already lost you. Did I lose you? Are you still here? Let me see. You are still here. So today, what we're doing today is this is the normal CCNA study stream. I don't know if you're familiar with any networking type stuff, but this is Cisco Packet Tracer we got up on here. I'm running this off of a virtual machine. This is a Windows virtual machine here that I'm running. and we're just doing some studying. And that's it. We're going over the topology, the router on the stick topology today. And then we're also going to be trying to finish part 5 today. All right. So, yeah, no, welcome to the stream, my good friend. Hope you can stick around. Love to have you stick around today, my good friend. All right. So, this is pretty much set up. Oh, I gotta update my nightboard. I'll do that afterwards. This is pretty much all set up now. We just have to configure it. But what we'll do is let's go ahead and do some reviewing on the actual chapter first. Okay. All right, chapter 17, IP routing in the local area network. This chapter covers the following exam topics: network fundamentals, configuring IPv4 addressing and subnetting, network access, configuring and verify layer 2, layer 3, Ethernet channel, all right, LACP, all right. The preceding 2 chapters showed how to configure an IP address and mask on a router's interface, making the router ready to route packets to and from the subnet implied by the mask, the address, and the mask combination. While true and useful, all examples so far ignored the local area network switch and the possibilities of VLAN. In fact, the examples so far show the simplest possible case. The attached switch as layer 2 switches uses only one VLAN with the routers configured in one IP address. In one IP address command on the physical interface. This chapter takes a detailed look on how to configure routers so that they would route packets to and from the subnets that exist in each and every VLAN. Okay, because layer 2 switches do not forward layer 2 frames between VLANs, a network must use a router to route IP packets between the subnets to allow those devices in different VLAN subnets to communicate. To review, Ethernet defines the concept of VLANs, while IP defines the concept of IP subnets. So a VLAN is not equivalent to a subnet. However, the set of devices in one VLAN are typically also in one subnet. So that statement is it could be very confusing or misunderstandable. So what it's stating is Ethernet does not define the concept of a VLAN. All right? A VLAN is its own. You have to think of a VLAN as being its own LAN, okay? And that is not a subnet, okay? It is its own broadcast domain, if that makes any sense at all. So that's why that statement has to be said the way it's said. So Ethernet does not define the concept of a VLAN, okay? That is because a layer 2 switch, you can add VLANs, okay? You don't primarily need to add. You don't need to say add a IP address to the switch virtual interface, the SVI, all right, and give that, an IP address and stuff like that. You don't need to per se do that. So it is not a actual subnet, all right. It is a broadcast domain that you assign inside of that layer 2 switch, okay? While IP defines the concept of IP subnets, so a VLAN is not equivalent to a subnet. However, the set of devices in one VLAN, are typically also in one subnet, okay? Again, that's where it can get a little confusing. By the same reasoning, devices in 2 different VLANs are normally in 2 different subnets. For two devices in different VLANs to communicate with each other. Routers must connect to the subnets that exist on each VLAN, and then the router forwards IP packets between the devices in those subnets. This chapter discusses the configuration verification steps related to the three methods of routing between VLANs with three major sections. All right, VLAN routing with router VLAN routing with router in 802.1q trunks. This first section discusses how to configure a router to use VLAN trunking as connected to a layer 2 switch. The router does the routing with the switch created. The router does the routing with the switch created the VLANs. The links between the router and the switch also trunking so that the router has an interface connected to each VLAN subnet. This feature is known as routing over a VLAN trunk, also known as routing on a stick. The ROAS, routing on a stick. One of my favorite ones to make is a router on a stick. All right. Next, though, this is where switch virtual interfaces come into face. Okay, but this is for layer 3 switches. Okay, so you need to have a capable layer 3 switch to perform this action. Okay, all right. VLAN routing, and we'll make that topology too. VLAN routing with layer 3 switches, SVIs, so switch virtual interfaces. The second section discusses uses a LAN switch that supports both layer 2 switching and layer 3 routing, called the layer 3 switch or multi-layer switch. To route the layer 3 switch configurations uses interfaces called switch virtual interfaces, SVIs, which are also called VLAN interfaces. Okay. All right. Next, VLAN routing with layer 3 switching, routed ports. The third major section of this chapter discusses an alternative to SVIs called routing ports, in which the physical switch ports are made to act like an interface on a router. This third section also introduces the concept of Ethernet channels as used as a routed port in a feature called layer 3 Ethernet channels. All right, so I'm actually very stoked to finally get into some layer 3 Ethernet channel discussion, because it's a little bit different than when we first learned about Ethernet channels. Okay. All right, let's take the do I know this already quiz. Router 1 has a fast Ethernet interface with IP address 10.1.1.1. The interface is connected to the switch. This connection is then migrated to use 802.1q on trunk. And which of the following commands could be part of a valid configuration for the router's 50 interface? Choose 2. So we need the, but it's not stating. So that and that. So A and F. I'm going to go with A and F. Even though it's not giving me the actual VLAN that it wants to trunk. These are the interface fast Ethernet 0/0 sub.4 would be the sub interface of 0/0 to say, like, this is the I'm going to encapsulate over VLAN 4. That's what that states. So we're going to go with, okay. Let's make that a little bit bigger. All right, so we're going to say 1. I'm going to say A and F. All right. Let's move down. All right. Router R1 has a router on a stick. Configuration with two sub interfaces of gigabit 0-1, gigabit 0-1.1, and gigabit 0-1.2. Physical interface gigabit 0-1 is currently in the down state. The network engineer then configures a shutdown command. The network engineer then configures a shutdown command when an interface configuration mode for gigabit 0-1.1 and a no shutdown command when the interface configuration mode for gigabit 0-1. Oh, boy, what the heck? All right, let me read that again. Holy stinking confusing question. Router R1 has a router on a stick configuration with two sub interfaces, gigabit 1 and 2. Physical interface 1, currently in the down. The network engineer configures the shutdown command on the interface configuration when in interface configuration mode. Okay, for that, and a no shutdown command when in the configuration mode. Which are the correct answers about the sub interfaces? C. Let's go with. Man, this is gonna be tough. Let's go with C and D on this one. Let's see how the dice rolls out. All right. A layer 3 switch has been configured to route IP packets between VLANs 1 and 2 and 3 using the SVI, which connects to the subnet 172.20.1.0/25, 172.20.2/25, and 172.23/25 respectively. The engineer issues the show IP route connected command on the layer 3 switch. Listed the connected routes. Which of the following answers list a piece of information that should be at the least on one of the routers? On one of the routes, I mean. Listed the connected routes. Which of the following answers list a piece of information that should be in at least one of the routes? Which of the following answers list a piece of information that should be in at least one of the routes? Man, these questions, I tell you, man, they're going to beat me up today. They are going to beat me up today. All right. Let's go with let's go with A. Let's say 3A. These chapters are getting harder and harder, Stan. They're getting harder and harder. An engineer has successfully configured a layer 3 switch with the switch virtual interface for VLAN 2 and 3. Hosts in the subnets using the VLAN 2 and 3 can ping each other When the layer 3 switch, when the with the layer 3 switch routing the packets, the next week the network engineer receives a call that those same users can no longer pay each other. If the problem is with the layer 3 switch function, which of the following could have caused the problem? Select 2 answers. All right. So what did you do? What did you do? 6 or more out of the 10 VLANs access ports failing due to physical problems could be 2 for the mode, BTP on the switch, removing VLAN 3 from the switch's VLAN list. That could be a problem. That actually could be BTP. That's definitely could be a problem. Let's go with BTP. It actually might be BTP removing the removing the VLAN. Because somebody would actually I don't know. It doesn't really state this physical problems. It doesn't state that somebody else could log into it. And again, it doesn't state that somebody. It means somebody could have logged into the switch and done the shutdown command. Let me pick. Oh, it's looking for 2, so let's pick D2. There is no VLAN 4, so that don't really matter. And it doesn't tell me how many ports there are. So, all right. A LAN design uses a layer 3 Ethernet channel between the 2 switches, switch 1 and switch 2, with port channel interfaces. With port channel interfaces 1 used on both sides. Switch 1 uses gigabit ports 0/1, 0-2, 0-3 in the channel. Which of the followings are true about the switch 1's configurations to make the channel to be able to route IP packets correctly? The IP address command must be on the port channel interface 1. IP address command must be on the interface on the lowest port. The port channel 1's interface must be configured with the no switch port. The interface gigabits. I'm gonna go with A. Oh, it's looking for 2, so I'm gonna go with A. I'm gonna go with A. Let's go at A and C on this one. I hate guessing. Guessing's no good. Guessing makes us feel like we don't know what we're talking about. So it's never good. Alright. I don't want to see the answers yet. Alright. A LAN design uses a layer 3 Ethernet channel between 2 switches. Switch 1 and switch 2 with port channel interfaces. 1 used on both switches. Switch 1 uses port gigabit 0-1 and gigabit 0-2 in the channel. However, only interface gigabit 0-1 is bundled into the channel and working. Thinking about the configuration setting on the port gigabit 0-2, that could have existed before adding the gigabit 0-2 to the Ethernet channel, which answers identify a setting that could prevent the iOS from adding gigabit 0-2 to the layer 3 Ethernet channel. So, different cost, different speed. So we need to choose 2 answers. So remember how they have to have the same speed, same. Yes, there we go. All right. So they need. So this don't matter. So it should be B and C. B and C on this one. I'm gonna say B and C on this one. 2 and 3. 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 2 and 3 Everything kind of needs to match. Let's see how we did, Stan the Man. Ooh, boy, I can see we got a couple wrong already. All right, we got this one right. Increase that a little bit. B and C. So this is wrong. We needed a B. You're wrong. We needed a C. This is right. Woo! This is right. Woo! And this is right. Woo! All right, let's go check out the ones we got wrong, though. So, start with 3. So, a layer 3 switch has been configured with the IP route to route packets between VLAN 1 and the SV on the switch virtual interface with connected to the segment respectively. The engineer issues the command on the layer 3 switch listing the connected routes, which are the following answers list piece of information that should be at least on one of the routes. The interface. All right, I get that. And then on 2, so I got C right, and then also it would put both of them on the down. So one would be administratively down, and the other one would be just be in the down state. Okay. I get you, mate. Let me get my sweet daughter to actually let me just get some. I'm gonna grab some instant coffee real quick here. Hold on, folks. Huh? What'd you say? What? Trying to see what it follows? Huh? Getting some coffee fired up for me. Well, getting some water on the kettle that way. We're gonna do is down some instant coffee real quick to boost me up there. Oh, how we doing out there? It's your boy Joe. Welcome to the stream. Hope you're having fun. Hope you're ready to get your learning caps on. All right. Let's get back into it. So, VLAN routing with router 8021.q. So that's let me actually get back to this before this locks out on me again. Why don't you just do this shit? Boop. All right. Let's grab some more switchies. Grab some of these empty ones. And what we'll do is we'll also, yeah, that's fine. So we'll set this up as our Ethernet group over here. We'll grab some more PCs. The reason why I'm doing this in Packet Tracer as well, guys, is so I don't blow up my computer today. That's it. All right. So we're gonna call you Big Sam, because you're the big guy. All right? You're the Big Sam. You guys know Big Sam? You know Big Sam? I have no idea who Big Sam is. Not a clue. Not a clue, man. All right, so we're gonna do 1, 2, trace. All right, let's just fill this bad Larry up, man. Fill him up. Bring them out, bring them out, bring them out, bring them out. All right, because that gives us 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That gives us 10. Let me yeah, that's fine. Fire it up. All right. We got that. We got that bad Larry fired up. We're gonna call you Little Sam. So we got Big Sam and Little Sam in his house today. All right, we're gonna fill you up with some gigabit ports too. These are all filled up. All right. So we got Big Sam, Little Sam filled up. All right. Let's name our PCs. So this is going to be, you're going to be VLAN 100. Can you see where I'm going with all this, guys? Can you see where I'm going with all this? You're going to be VLAN 200. Not VLAN. VLAN. You're going to be VLAN 300. All right. Router on a stick. This is going to be our Ethernet, our layer 3 Ethernet channel configuration. All right. So that's what we're going to use for this one. And what was the other one that it was going over? SPIs and then switch ports. Switch port routes. All right. So this one we're going to have to read a little bit more about on how to correctly configure that one. This one I have an idea on how to do. Oh, wait. Yeah. Oh, I get this. All right. So what I just actually, so this would be routing layer 3 switchings over switch ports. So that's what I set up here. And then just to set up the other one, that one's just real easy. I don't know why I overcomplicated that. So let's just view just slightly over here. Let's see another router. A router. And this is why I'm doing it in packet tracer today, guys. Because I would not be able to shut up all these things. Well, I could, I guess, but my computer would be hating me if I did all this to it tonight. And I love my computer. All right, we're going to call you. We're going to call you Thomas. He's Thomas. Thomas the Switch. Do you know Thomas the Switch? Do you know Thomas the Switch? We only need 1, 2 tray ports on you. Trace ports. All right. You're going to be VLAN. You're going to be VLAN. I got a names for VLANs over here. VLAN 15. There we go. VLAN 30. No, I already have a VLAN 30. We can be VLAN 25 then. Alright, I think my kettle's fired up. And then you can be VLAN 35. Alright. So we got that set up. Let me go grab my kettle. So I can have me some coffee. Think I got enough instant coffee to get us through the stream, guys. I got me kettle. I got me kettle. I don't know if that's a good idea, man. But we're gonna do it anyways because I'm crazy. Yeah. All right. The almighty mitt. Don't make me give you the mitt, man. Don't make me do it. I think I've lost it finally, guys. Remember in basic training, we used to eat this stuff just to stay awake. Well, mainly because it came in our MREs. How's everybody doing, though? How's everybody doing? Hanging around with Crazy Joe today? You guys must be crazy for hanging out with me, huh? How much should I put in this? 1 teaspoon for a small, 2 for large. We're gonna say 4 for Joe. Right. Instant coffee time because I don't have time to make ground coffee or the energy. And because sometimes instant coffee is actually pretty good. The best part of waking up is some Joe in your cup. Oh, ha, ha, that's a hot tamale. That's a hot tamale, yeah? Ah, that's a hot. I like it. I like it a lot. All right. All right, let's do it, boys and girls. Let's stop playing around here. I'm messing around. Yeah, 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 yeah. It's all connected. Mr. Biggs. Mr. Biggs. Is that going to even work for me? Might not. Check that. One, two, three, 4, 5, 6. So it's 6. How many more ports do I have available? I just have enough. Okay. Now, All right, so I got the last four interfaces left. Um, good. Anything in excess? All right. So that is, we're all set up for our configuration demonstration. Yeah. That we'll be doing today, and these are the three. These will be the three configurations that we'll be going over. Okay. We have that. Oh, look at you! You're all kinds of crazy named. Fix yourself, fool. All right, very good. We good. All right, let's get back. Let me close this out. This out. There we go. All right. So we have VLAN routing on a stick with 802.1q trunking. There you go. That's the server. Okay. VLAN routing with SV with switch virtual interfaces. That'd be here. Okay. And then VLAN routing with layer 3 switch ports. And that'd be here. All right. The switch port one is the one I'm actually most interested in, just because that's an actual configuration that I haven't actually myself gone over yet. So I'm actually pretty stoked and pretty pumped up to go over that one with all of you guys today. So let's get into it. I just need to take a shippy of my copy. Hey, anybody in chat it up. Feel free. Let me what do we got? Is Stan still out there? My main man Stan. I'm gonna send me a hug up to Mr. Stan. Ooh, there's a virtual hug, my good man Stan. You guys want to know the weather where I'm at too? You guys can always check your weather. Yeah, you guys want to take a look at my weather today? Chitty chat, chitty chat, chitty chat. What up, my muffin? Guys want to check your own weather? Just do the exclamation point, my weather, no space, my weather, and then put the city and state on where you live, and it'll tell you the weather. That's the weather where I'm at. We have a cloudy, slightly cloudy with temperatures in the 31 degrees out today. Ooh, with a slight blowing north wind breeze, 10 miles an hour. Not too bad today. I'll take it. I will take it. All right. Oh, what's up? What is that? John Sayaba. Good looks on the follow. Am I saying your name right? Jane Sahab. Jane Sahab, what up? How we doing? Here's a hug from me to you. Have a hug. You deserve a hug. I'm good, my friend. I am good. Pumped up. Pumped up. You know what? It's going pretty good. It's going pretty good. I tell you, chapter 16 is just been hurting my brain. I just have been working way too much and trying to study at the same time. But the prep's been going good. The prep's been going good. Tonight we're over here in chapter 17, going over IP routing and over LAN devices. So we're going to be getting into the router on the stick, VLAN routing over layer 3 switch virtual interfaces, and then VLAN routing over switch ports today. This one right here, VLAN routing over switch ports, which over switch routed ports, is actually one I'm actually pumped up about, because that's one configuration I guess I haven't really spent too much time. Actually, I haven't configured it yet, so pretty stoked about getting that configured today. We're up in here in Cisco Packet Tracer today, trying to give my computer a break by not using Cisco Modern Lab to do this madness today. But yeah, I'm pumped up, man. Pretty pumped up. That's it. So, all right. Yeah, it should be fun. Drink some coffee before we get into this. All right. How you doing today, though? How you doing today? All right, so we went over the Do I Know This Already quiz questions just a minute ago. Thanks you, man. Yeah, that's it. I just got to keep grinding through it. Keep grinding through it. You know, I can't wait. I can't wait to finally take the exam, you know. Ooh, some advanced Python, huh? I love me some Python. So I can't wait to spend more time diving into more Python. That'd be the next thing with the DevNet cert that I'll be spending more time on. I've spent some time learning Python. I wrote a calculator in Python. It's an IPv4. It's an IPv4 information finder. It's not so, even though I call it a calculator, it's not really a calculator. It'll take your IPv4 address and it'll just tell you if it's a private or if it's a public IPv4 address, and it'll just give you some information on it. It's probably broken now because I think I wrote it in 3.6, and I think 3.9 breaks it totally. I had it up on Git. It's still up on GitHub. But like I said, I think it's broken now because of 3.9. But yeah, man, Python's awesome, dude. I love Python. I tell everybody to a good starting language to learn is definitely Python. It's just so yeah, big time. But every time they up, it's usually like they say like after 2.7, like the 3-point stuff wasn't supposed to break so often, but the 3-point stuff still breaks as much as converting over from 2.7 to 3 whatever now. Seems like every step that they take and it continues to break, so you got to make sure your modules are always up to date and whatnot. But it's all good. Python's fun though, man. Python's an amazing language. It's fundamental. It is super, super fundamental, and it's got such a big grip. It's got such a big grip on everything. Right. It's heavenly bliss. All right. Fundamental topics. VLAN routing with router 802.1Q trunks. Almost all enterprise networks use VLANs to route IP packets in and out those VLANs. Some devices, either routers or layer 3, big one, layer 3. All right, because remember, layer 3 switches deal with they can deal with IP routing. Okay, all right. Layer 2 switches, again, they don't deal with IP routing, okay? They're just strictly layer 2, okay? I think when you hear layer 2 and layer 3, think back to the OSI model, think back to the TCP/IP model on how that correlates to the capabilities of that layer switch, okay? All right. Need to have some IP addresses in each subnet to have connected routes to each of those subnets. Then the IP address of those routers or layer 3 switches can serve as a default gateway in those subnets. These chapters break down the local area network routing options in the 4 categories. Use a router with one router local area interface and cable connected to the switch for each and every VLAN, typically not used. All right, and we're going to be using the sub interfaces. Okay, sub interfaces. All right, use a router with the VLAN trunk. Use a router with VLAN trunk connected to the LAN switch known as router on a stick. My most favorite configuration. Use a layer 3 switch with switches with the switch virtual interface, SVI, switch virtual interface. Okay, so when you switches, obviously, so you can break a layer 2 switch to have VLANs, okay? But a layer 3 switch has the capability to have a switch virtual interface. So that's when it can be assigned an actual IP address, okay? All right. So that's the difference between a layer 2 and a layer 3 switch, at least from my understanding so far. So, use a layer 3 switch with router interfaces, which may or not be layer 3 Ethernet channels. Of the items in the list, the first options work, but to be practical, it requires far too many interfaces. Is mentioned here only to make the list complete. As for the 3 options, this chapter discusses each in turn as the main focus of one of the 3 major sections in the chapter. Each feature is used in rail networking today, with the choices to be used one or the other, driven by design in needs for a practical part of the network. The figure shows in case which of these options could be used. Okay, so we have so here we go. So here's some layer 3 switches. So we got our layer 3 switches right here. Ooh, that's a horrible color. Use red. All right. So we got our layer 3 switches right here. All right. These are like acting probably like the distribution switches, or like in the leaf or tree. No, the leaf spine design, where you got the big guys acting as the leaf, and then the spine. You got the big guys acting as the spine, and then you got the other switches acting as the leaf. Yeah. Where all these, if I'm saying that right, all these leaf switches, that's where you're seeing all these Ethernet channel ports and everything. So that everything's only 2 hops everything's capable of only being 2 hops away from each other. And you can have an array of switches, and each one only being actually 2 hops away. Oh, no doubt. Yeah, dude. Dude, you can lurk all you want, my good friend. I appreciate you being here, and I appreciate the follow. So, like I said in the beginning of the stream, you just made me 9 follows away from actually being an affiliate, man. So I'm pretty pumped up. Thank you so much, man. I've been working, I've been at this for a little bit now, and I can't wait to hit 50 followers, man. I'm so close, man. And you just made me 1 closer, my man. So good looks, man. Lurk all you want. If you have any questions, just pop in whenever you want. I'm doing everything I can to monitor the chat as we go. So I'm pretty good about monitoring the chat. So, all right. So, so that's this type of design right here. And then this gets into sort of kind of like the router on the stick. Yeah, so I mean it's pretty much like it's stating layer 3 switch at a central site. This is a pretty neat topology here where I mean it's stating some VLAN trunking. So what do we got? We got two. So it's pretty much stating that each of one of these switches have multiple has at least two VLANs off of each one of themselves. This would be the core router here. And this is probably going back to the corporate office. You know what I'm saying? Where these are probably like remote sites, maybe. All right, that's all I can really gather from what this topology is telling me here. Nope. Oh, I want my mouse back. All right. All right. The figure shows two switches labeled A and B, which could act as layer 3 switches, both with switch virtual interfaces and routed interfaces. The figure shows a central site campus local area network on the left with 12 VLANs. Switches A and B act as layer 3 switches combining the functions of a router and a switch, routing between all 12 subnets, VLANs, as well as routing to and from the core router. Those layer 3 switches could use switch virtual interfaces or both. All right. Also shown a classic case for using a router with VLAN trunks, sites like remote. Yeah, so exactly. So it's stating that these are like the remote sites right here. Sites like remote sites on the right of the figure may have a wide area network connected router and a local area switch. These sites may use the router on a stick topology to take advantage of the router's ability to route over 802.1q trunking. All right. Note that the figure just shows an example. The engineer could use layer 3 switches at each site or routers with VLAN trunking on each site. Okay, so it's just a quick example of that. All right, configuring the router on the stick topology. The next topic discusses how routers route packets to subnets associated with VLANs connected to a router 802.1q trunk. That long description can be a bit of a chore to repeat each time somebody wants to discuss this feature. So over time, the networking world has instead settled on a shorter or more interesting name for this feature: the router on a stick, the ROS, the ROS, I guess you would say, ROS or ROS. The router on the stick uses a router VLAN trunk configuration to give the router a logical router interface connected to each VLAN. Because the router then has a interface connected to each VLAN, the router can also be configured with an IP address in the subnet that exists on each VLAN. Routers use a sub interface as the means to have an interface connected to the VLANs. Routers need to have an IP address / mask associated with each VLAN on the trunk. Okay. However, the router has only one physical interfaces for the link connected to the trunk. Cisco solves the problem by creating multiple router interfaces, one associated with each VLAN on the trunk, at least for each VLAN that you want the trunk to support. Okay. Cisco calls this feature virtual interface. All right, virtual interfaces, sub-interfaces. Okay, sub-interfaces. The configuration then can include the IP address command with each sub-interface. And we're going to configure these together, guys. Okay, that way you guys can see the actual configuration. And this is one that I've gone over time and time again. So I have this configuration pretty pat. All right. So, all right. The figure shows the concept with router B1 on the branch router on one of the branch routers. from the figure. Because this router needs to route between the two VLANs, the figure also shows the two interfaces named gigabit 0-.10 and gigabit 0-.20, which create a new place in the configurations where the per VLAN configuration settles can be made. The router treats frames tagged with the VLAN 10 as they came in or out of gigabit 0-.10 and the frame tagged with VLAN 20 as if they came from gigabit 0-.20. Okay, so we got some VLAN tagging going on here. All right. In addition, note that most Cisco routers do not attempt to negotiate trunking, so both the router and the switch need to manually configure trunks. This chapter discusses the router side of that trunking configuration. The matching switch interfaces would need to be configured with the switch mode trunk. Okay. All right. The example shows 802.1 trunk and configuration is required on router V1. More generally, these steps detail how to configure 802.1 trunking on a router. Okay, so here's our configuration step checklist. So interface, all right, encapsulate .1q, IP address. We're going to go through this, guys, so don't worry. First, look at the sub-interface. The sub-interface number begins like a period, like 0.10 and 0.20 in this case. These numbers can be any number from 1 up to a very large number, over 4 billion. Yeah, so have 4 billion sub-interfaces. The numbers just need to be unique among all the interfaces associated with the physical interface, okay? In fact, the sub-interface number does not even have to match the associated VLAN ID. The encapsulation command and not the sub-interface number define the VLAN associated. So what that's saying is the sub-interface number that you're assigning to the actual sub-interface does not matter. It's just the number for you, the network engineer. So, I mean, I usually just keep it the same just to keep things, tight, I want to say. Tight. But it states that it does not need to match. What needs to match is the encapsulation, what you're telling the router to, when that tag comes in, it needs to have that correlating, that needs to match. So the encapsulating data that you want that router to route packets in that VLAN, it needs to know where that encapsulated data is coming from. So that's the VLAN tag. So that's what matters, is when you use the command encapsulate VLAN whatever, that's where you assign the actual pertaining VLAN number, and that's where it matters, okay? I love instant coffee. I don't know why. People think it's gross. I don't think it's that bad. And I drink it straight black. I drink all my coffee black. People think I'm crazy for that one, too. Whatever. All right. Although not required, most sites do not choose to make the sub-interface numbers match the VLAN ID. Although not required, most sites do choose to make the sub-interface. Yeah, exactly. Just to avoid confusion. Yeah, I don't know why you would make things crazy on yourself. I mean, if you're a psycho, maybe. But that's on you. Each sub-interface configuration lists two commands. One command, the encapsulation, enables trunking to and defines the VLAN whose frames are considered to be coming in and out of the sub-interfaces. The IP address command works the same way it does on any other interfaces. Note that if the physical Ethernet interfaces reaches an up state, the sub interface should as well, which would then let the router and the connected routes show at the bottom of the example. Now that the router has a working interface, the IPv4 addressing configured, the router can route IPv4 packets on these sub interfaces. That is, the router treats the sub interfaces like any other physical interface in terms adding the connected routes matching those routes and forwarding packets to and from the connected subnets. The configuration and the use of the native VLAN on the trunk requires a little extra effort, little extra thought. The native VLAN can be configured on a sub interface or on the physical interface, or ignored as in the example. Each 802.1q trunk has one native VLAN, and if the router needs to route packets for the subnet that exist on the native VLAN, then the router needs some configurations to support that subnet and two options to define a router's interface for the native VLAN. Okay. So configure the IPv4 address command on the physical interface, but without an encapsulation command. The router considers the physical interface to be using the native VLAN. All right. Configuring the IPv4 IP address command on the sub interfaces and use the 802.q.1 VLAN ID. Native subcommand tells the router about the VLAN ID and the fact that this is the native VLAN. Okay. So you give it the VLAN ID, and then you just state that that's the native VLAN. All right. All right. Shows both native configuration options, with the small change to the same configurations. In this case, VLAN 10 becomes the native VLAN. The top part of the example shows the option to configure the router's physical interface to use VLAN 10. The second half of the example shows how to configure that same native VLAN on a sub interfaces. In both cases, the switch configuration also needs to be changed to make VLAN 10 the native VLAN. So we're in gigabit 0-0. We got the IP address. There we go. Encapsulate.1q. Yep. All right. So here we go. We're in and out an interface. Gigabit 0-0.20. We're encapsulating .1q 10, and we're identifying that as the native VLAN now. All right. So that's all. That's all it's pretty much doing is you can either, so the associating, it'll either associate. Oh, I missed something. You can find some really good sources to make prep a bit easier on Reddit. Also, there is a Udemy course by David Bumble. It's really good. Yeah, I got. Go looking out on that. Yeah, I purchased David Bumble's entire CCNA prep course. I purchased the big one, the one that has like 900 videos in it. I purchased that too. And what you're seeing here, I also have a subscription to O'Reilly Media where I get everything. I get free. Well, it's not free. I pay for all of it, and it's pretty hefty. It's a pretty hefty subscription. But this is how I've learned a lot in just a short amount of time with everything. Because I get access to live training courses. I get I've taken classes with Weldon Odom. I've taken classes with who's that other one? Oh, I can't remember his name now. The other big guy. Kevin Wallace. I've taken live courses with Kevin Wallace. Yeah. So I've taken. So the O'Reilly, I tell you what, the O'Reilly Media subscription, even though it's expensive, it's about $40 a month. That's pretty expensive, all right. But at least for me, it's expensive. It is worth its weight in gold, my friend. Worth its weight in gold, because not only do I have, do I get the ability to take live courses with these awesome people, I also have access to all of every single Cisco book, every single anything book, anything Pearson touches, I have access to. I have access to all the Pearson test prep stuff. That's what I was taking that's what usually when I start my stream, we usually start up with a Pearson test prep questionnaire just to make my brain hurt a little bit. So yeah, definitely. The on Reddit again, I there is a lot of good stuff on Reddit. I know that. It's just I try to stick with the actual source material. David Bumble is a huge. Yeah, I love David Bumble. He was the one who actually that sparked. He sparked the flames within me to get me pumped up about doing this. I don't know how long you might have been following me, or I don't know. Is this your first time coming on the stream? If it is, what had happened was back in February I end up yeah, exactly. So back in February, I end up injuring myself pretty bad, and I was pretty much paralyzed from the waist down. And for about 6 months, I lost the ability to walk. So I was hurt up. I ended up losing my job and everything. It was a bad, rough, and I'm just actually crawling back out of this now. But during that time that I was laid up, obviously I was doing a lot of like YouTubing and just playing video games and whatnot. And just for instance, I came across a David Bumble YouTube video, and boy, dude, I fell in love with that cat, man. He's an awesome fella, man. I tell you, I don't know. He is a content creating machine. I mean, just from his YouTube videos, his motivational things that he releases all the time, his Discord channel. He is such an awesome dude. I love me some David Bumble, dude. Shout out to David Bumble. You the man, David Bumble. He's an awesome dude, man. I love that cat. But yeah. So that's how I got sparked up, fired up into this whole thingy, and I can't wait. I'm in college now too. I'm trying to get my bachelor's degree in information technology too at the same time. So he really sparked a flame within me because I'm going after my bachelor's in this stuff now. Obviously, I'm trying to go after all these certifications too. Yeah, his Udemy courses are great. They'll give you a headache because he goes into so much detail about everything. I think let me say, I don't know if I've even gone through all 900 videos, but I've gone through a pretty fair share. Did you get your bachelor's in IT too? See, I can't wait. So I'm only like 4 months into it, and obviously I got to go through all my prereqs and all that. Yeah, you gotta watch them at 1.25 times speed. That's so true. Did you get in computer science? So that's what I was thinking about getting in computer science. That I was weighing my options between IT and computer science. Because honestly, the IT one, I didn't even thought there was a bachelor's degree for IT. I knew there was all because my sister has been going to school for computer science. But then the University of Phoenix, they struck me with, they had a bachelor's degree program that they were just starting that was just solely a bachelor's degree in information technology, because of where I wanted to take my education, because I want to get into I wanted to get heavily into virtualization, into the pretty much like cloud networking and stuff like that, AWS, Google, Rackspace, Azure, and stuff like that, because my interests align where I want to take my education. I want to take my education into the public sector, where I can make improvements on, state and city, local government apps, interfaces, web interfaces for welfare services, childcare services, healthcare services, stuff like that. Because I honestly feel that the public sector is so behind the technology. There's a huge technology gap that the public sector hasn't crossed yet, where the private sector is like eons ahead of the public sector, and I think it's kind of unfair that the public sector itself has been so ignored, and that I just feel if folks pay a little bit more time and invest in trying to improve public sector technologies, that the quality will actually create a better quality of life for everybody. You know what I'm saying? Well, you know, healthcare, childcare. That's a one that really sticks out for me, is making sure that children, you know, when they enter into the system, you know, unfortunately, if a child has to enter into like the system or whatnot, that these kids are being tracked, they're being taken care of, they're being monitored by, you know, an application that, you know, a human tends to always fail at these things, and children end up falling through the gaps and getting hurt, and not getting the proper health care, not getting the proper education that they deserve. So yeah, data science is huge in medical. Oh, I know, and that's the big problem, is that they don't spend enough money because they think it's not important. Uh, they don't think it's important, and what I'm hoping to do is to make a drive to make it important, to make a stand that it should be an important thing that the public sector does, because of the quality of life, the improvements, the savings that it will bring later on. You know, it's the whole thing. You spend X now, and you're gonna save Y later. That's what I want to bring to the table and show them. Also, I have other ventures that I want to go down too, especially, you know, with things revolved around recycling and stuff like that. Because I was in the recycling industry for a while, and the thing is we shouldn't be exposing human beings to hazardous chemicals anymore. It's an uncalled for thing. We should not be putting human beings or any carbon-based life form. We shouldn't be exposing them to harmful chemicals anymore. We have robots for that shit. We should be creating engineered robotics to take care of harmful waste disposal. You know. But yeah, so I mean, I have a couple of ventures that I want to take under once I get, you know, obviously I have so much I need to learn. And the thing is like I'm trying to. That's why the CCNA for me is so important, because I strongly feel that the CCNA certification, because of the broad scope it actually covers, is a super awesome and important certification for anybody entering into the world of IT. It's like it should be. I mean, it has been and it still should be the fundamental certification that any IT person should take, because if you don't know, again, because of the scope that it covers, you'll just check all your boxes of knowledge after the CCNA course. Obviously, you're gonna have to go into more depth depending on whatever you want to go down to. I'm gonna go, you know, CCNA DevNet. You know what I'm saying? Because I want to go to the field of automation and programmability. And stuff like that. So it'd be CCNA DevNet. Also, I'll be going after my CCNP and my the higher level DevNet associate. The higher level DevNet certifications after that. But that's the direction that I'm going to take. But you know, it kind of starts there. But yeah, super pumped up, man. Super pumped up. We need more coffee. It's coffee time. Instant coffee. Yum, 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 yum. All right. Let's continue on. By using the show run config command, the router on the stick configuration on a router can best verify verify which two commands to show IP connected to the show VLAN As with any router's interface, as long as the interface is in the up and the IPv4 address configured, iOS will put a connected and local route in the IPv4 routing table. So a first and obvious check would be to see if all the expected connections route exist. The list connects in the example routes per configuration shown. So this is just going over the show IP route. I'll sleep now. Take care. I'll see you around. You got it, my man. Hey, thank you again for joining the stream, my friend. Make sure, if you obviously you follow, so you'll get the notifications. And, I do this weekly. I do this daily. The weekends are kind of touch and go. That's like my family time. But you have a good night. Get some good sleep. All right, my friend. Thank you again for the follow, my friend. Whoop whoop. All right. As for interface and sub-interface state, note that the router on the stick interface state does depend on some degree of on the physical interface state, and particularly the sub-interface state cannot be better than the state of the matching physical state. For instance, on router B, in the example so far, physical interface gigabit 0-0 is in the up state, and the sub interface are in the up state. But if you are unplugged, if you unplug the cable from the port, the physical port would fail to the down state, and the sub interfaces would also fail to the down state. Shown in the example, the physical interfaces being shut down, with the sub interfaces then automatically change to administratively down state as a result. Very good. All right. Additionally, the sub-interface state can also be enabled or disabled independently from the physical interfaces using the no shutdown command and the sub-interface configuration command. Another useful router on a stick verification command, show VLANs, spells out which router trunk interfaces uses which VLAN, which VLAN is the native VLAN, plus some packet statics. The fact that the packet counters are increasing can be useful when verifying whether traffic is happening or not. And the example shows a sample based on the router B's configuration, in which the native VLAN 10 is connected to subinterface gigabit 0-0.10. Note that the output identifies VLAN 1 associated with the physical interface. VLAN 10 is as the native VLAN associated with a gigabit 0-0.10, and VLAN 20 associated with a gigabit 0-0.20. It also lists an IP address assigned to each interface sub-interface. Okay, so here's the show VLAN command. It's just showing us some information, showing the actual physical inner ports here. Okay, this is configured for the native VLAN. Okay, here's the IP addresses. Okay, it's just telling us some more information. All right, troubleshooting. The biggest challenge with troubleshooting the router on the stick has to do with the fact that if you misconfigure only the router, if you misconfigure only the router or misconfigure only the switch, the other devices on the trunk has no way to know that the other side is misconfigured. That is, if you check the show IP route or the show VLANs command on the router and the output looks like it matches the intended configuration, and the connected routes for the correct sub-interface to show up, routing may still fail because of the problems on the attached switch. So troubleshooting the router on the stick configuration often begins with checking the configurations on both router and switch, because of there is no status output on either device to tell you where the problem might be. First, check the router on the stick on the router. You need to start with the intended configuration and ask questions about the configuration. Is each non-VLAN configured on the router with the encapsulated .1Q VLAN ID command? Does the same VLAN exist on the trunk on the neighboring switch? Okay, so the source interface trunk, and they in the allowed list, not VTP or pruned, and not STP blocked. Okay. Does each router on a stick sub interface have an IP address / mask configured per configuration? If using the native VLAN is it configured correctly on the router, either on the sub interface with the encapsulated .1q VLAN native command or implied on the physical interface? Is the same native VLAN configured on the neighboring switch trunk in comparison to the native VLAN configured on the router? Are the router physical or router sub interfaces configured with the shutdown command? With some of these steps, you need to be ready to investigate possible VLAN trunking issues on the LAN switch. The reasons it is that on many Cisco routers interfaces do not negotiate trunking. As a result, router on a stick relies on the static trunk configurations on both the router and the switch. If the switch has any problems with VLANs or the VLAN trunking configurations on its side of the trunk, the router has no way to realize the problems exist. For example, imagine you configured the router on a stick on a router that, just like in the example, however, the switch on the other hand, on the other end of the link, has no matching configurations. For instance, maybe the switch did not ever define VLAN 10 or 20. Maybe the switch did not configure trunking on the port connected to the router. Even with the blanket configurations or missing configurations on the switch, the router still shows the up on the router stick interface and the sub interfaces IP routes in the output of the show IP route and meaningful configurations information in the output of the show VLAN commands. Okay. All right. So we got through that. Now let's get a log out. All right. So let's head over to here. Let's dive into it. All right. So we only have one, and that is gigabit 0-0. All right. Interface gigabit 0-0. All right. Let's keep the IP addressing very, very simple. Okay. Shut. Okay. And then, all right, so on the physical interface, I gave it the address of 10.0.0.1 and the /24 subnet mask. Very simple. So this is the physical interface, okay? Now, let's make a native interface. So we're gonna make a native interface for native VLAN 1. All right, this is just the way I like to do this type of configuration. So interface gigabit 0-0 0-0.1. All right, now I'm moving into the sub interface. Okay, all right. Now we're gonna say encapsulation .1q 1 native. All right, because I'm gonna tell it that I want VLAN 1, because I'm going to make VLAN 1 on the switch, the native VLAN, and that's going to be the one that's going to be trunking over, okay? There we go, okay? Give it an IP address, all right? 10.0.0.1.1, all right? 25.25.25.0. No shot, okay? Or even give it a description. VLAN 1. All right. Now let's move into interface. Gigabit 0-0.10 now. Encapsulation .1q. I'm going to say 10. Okay. IP address 10.0.10.1. 245, 245, 245 dot 0. Give it the no shut. Give it a quick description. All right, we're going to call you VLAN 10. Okay. Now we're going to go into interface, gigabit 0-0, 0.20 now. Encapsulation, got 1Q, 20, IP address, 10.0.20.1, 245, 245, 245.0. Give you the no shut. And we're gonna say description, VLAN 20. All right. Last one, gigabit 0-0, 0.30. Same thing, encapsulation, .1Q, 30, IP address, 10.0.30.1, 255, 255, 255.0, no shot, and then description, VLAN 30. Okay. Exit. Let's give this a quick a do ride. All right. All right. So let's do this now. IP, DHCP, pool, VLAN 10, network, 10.0.10.0, 255.255.5.0, default, 10.0.10.1. All right, IP, DHCP, pool. We're going to say VLAN 20. Say network. 10.0.20.0, 255.255.255.0. Default 10.0.20.1. All right, IP, DHCP, pool, VLAN 30, network 10.0.30.0, 255.255.255.0, default 10.0.30.1. All right, exit, and do right. And I believe that's it. Do, show, run. So we got our DHCPs. Then we have our interfaces here. So let's do a do, show, VLAN. What was that command? VLANs. VLANs. This router might not have it. Yeah. This router might not have that actual command. It's okay. We can do show. That's cool. All right. All right. Now let's come over here to the switchy switch. All right. Now we're gonna go into its termination, its terminal mode, configuration terminal mode. All right. So we're gonna say VLAN 10. All right. Name. VLAN 10. All right, VLAN 20 now. Name, VLAN 20. VLAN 30. name VLAN 30. All right. Now let's move into what's our physical port here. So 0-0-1. So let's go to gigabit 0, 0-1. I'm gonna say switch port mode trunk. Right. Right. So now let's go into interface. What is our other interfaces? 1, 2, and 3. Oh, 1 and 1. Okay. So we're gonna say switch port, access, VLAN 10. All right. Interface, gigabit 2-1. Switch port, access, VLAN 20. All right. Interface, gigabit 3-1. Switch port, access, VLAN 30. All right, and that should be it. So do a do right. All right, let's exit out of this mode, and we can do get we can do a do show interface trunk. All right. So we're looking at our trunks now. Trunking over VLAN 1, gigabit 0-1. It's trunking for 10, 20, and 30. So we're good. So let's do a do right. Make sure we save that configuration. Let's come over here. Now if all is good, DHCP should statically configure us an address, and it did in the correct. So as you can tell, DHCP, we got a dynamic address and the correct VLAN 10.0.10.2. All right, so that kind of gives us the hint that things are actually working properly. Go to VLAN 20 now. And again, we got a dynamic address in the correct VLAN at 10.0.20.2. And we'll come over here and do the same thing. And we got a dynamic address in the correct range. And our address is 10.0.30.2. Alrighty. So let's go over to our desktop. Let's come over to our thingy. Let's send a ping to 10.0.10.2 and see if we can ping our other routers, our other host at least. And there we go. And now we have communication to our other hosts. So that's the quick and skinny of the router on the stick configuration right there. Again, this is one of my most favorite actual type of configurations to go over, just because I think it's just so neat. It's too bad that this router image is not showing the show VLAN. Show. Yeah, it doesn't have it. Doesn't have the show VLAN command. And that one has the show VLAN command, but it's kind of hard to see. I guess it's not really that hard to see, but there's our VLANs right there. Doesn't have the show VLANs, so. No, it doesn't have the show VLANs command. So yeah. So again, that's the quick and easy, the skinny on that type of configuration. Now, let's move on to the switch virtual interface type configuration. I'm just gonna make myself some more coffee. Wrong stuff at myself. I'm throwing stuff at myself over here. Alright, just wanted to check on my other streamy streams to see how they're doing. Shout out to my boy Paul. He just started a new job. Starting a new job is never easy. So shout out to him for having the courage to try a new job and to make it happen. So Paul, if you're out there, if you're watching right now, my brother, I wish you all the luck in the world, man. Good luck to you, all right? And I know it ain't easy starting a new job, and it's all stress. You know, I just hope and pray that that things will settle down for you, and you'll find your way in your new job, and your new employer will be satisfied in your skills and your abilities, and you'll do great things, my friend. So good luck to you, my friend. You've been a very supportive individual in this whole entire time, so I appreciate and love you, all right? Thank you. Just whipping up some more Insta coffee. Paul knows all about that Insta coffee, don't you, Paul, in basic training? What keeps you alive, keeps you awake. Oh, it's like mud now. Ooh, that mud coffee. Yum, 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 yum. All right, let's move on. All right, switch virtual interfaces now. All right. VLAN routing with layer 3 switch virtual interfaces. Using the router on a stick to route packets makes sense in some cases. Particularly at small remote sites. In sites with large local area networks, network designers choose to use layer 3 switches for most inter-VLAN routing. A layer 3 switch, also called a multi-layer switch, is one device, but it executes logic at 2 layers. Layer 2, local area network switching, and layer 3, IP routing. The layer 2 switch functions forwards frames inside each VLAN, but it will not forward frames between VLANs. The layer 3 forwarding routing logic forwards IP packets between VLANs. Layer 3 switches typically support two configuration options to enable IPv4 routing inside of the switch, specifically to enable IPv4 routing switch interfaces. This section explains one option in options that uses switch virtual interfaces. The final major section of the chapter deals with the other option for configuring IPv4 addressing on a layer 3 switch, routing interfaces. Okay, so we're going to be dealing with switch virtual interfaces and then routing interfaces. Okay, configuring using switch SVI, switch virtual interfaces. The configuration of a layer 3 switch mostly looks like layer 2 switching configurations shown back in parts 2 and 3 of this book, with the small bit of configurations added for the layer 3 switch function. The layer 3 switch function needs a virtual switch connected to each VLAN internally to the switch. These VLAN interfaces act like router interfaces with an IP address in MAS. The layer 3 switch has an IP routing table with connected routes of each of the VLANs. The interfaces also refer to it as the switch virtual interface, the SVIs. Okay, to show the concept of the layer 3 switching, the SVIs, the following examples use the same branch office with two VLANs shown in the earlier example, but now the design will use a layer 3 switching in the function with the router configuration concept for the layer 3 switch function with a router icon inside of the switch to emphasize the switch routes packet. So this is just an example of it's just showing you that it's logically acting as a router. Okay, it's not a router, it's just logically acting as a router. Okay, so interface VLAN. So these are the switch virtual interfaces now. All right. Routing on VLAN's interface switch. Note that the figure represents the internals of the layer 3 switch. Within the box in the middle of the figure, the branch still has two users, VLAN 10 and 20. So the layer 3 switch needs one VLAN interface for each VLAN. The figure shows a router icon inside of the gray box to represent the layer 3 switching function with layer 2 function interfaces on the right side of the icon. In addition, the traffic still needs to get to a router, B1, a physical router, to access the wide area network. So the switch uses a third VLAN wide area network, 30 in this case. So this is just representing if you're still connected to the internet, you're gonna want to need a router to route out to the wide area network. Okay, all right. And that's what I guess the new Cisco platform, they call it the platform, not a router, not a switch, not anything like that. It's the Cisco platform. All right, it kind of, I guess, encapsulates all of that now. But I have no idea. I haven't even got that far yet. The physical links between the layer 3 switch and the router B1 would not be a trunk, but instead of an access link. Okay. The following steps show how to configure layer 3 switching using SVIs. Note that some switches, like the 2960 and 2960 IR switches used for the example in this book, the ability to IPv4 routing packets must be enabled first. With the reload of the switch requires to enable the features. The steps that occur after the reload would apply to all methods of Cisco switches that are capable of doing layer 3 switching. So enabling IPv4 routing on a switch also needed. Use the SDM preferred LAN-based routing command, or similarly in the global configuration mode, to change the routing forwarding ASIC settings to make space for IPv4 routing. on the next reload of the switch. Use the reload exec command to enable mode to reload, reboot the switch to pick up the new SDM prefer. Okay, so the SDM prefer local area network based routing. That's all you're telling it to do. All right. Once reloaded, use the IP routing command in the global configuration mode to enable IPv4 routing functions in the iOS software. Enable the key command like show IP route. All right. Configuring in switch virtual interface 1 per VLAN for which routing should be done by the layer 3. Use the interface VLAN ID. All right. Use the IP address like you would, the no shutdown. All right. So same thingy here. Verifying the switch virtual interfaces. Yep. All right. And all right, let's just jump into it and see if we break it all. All right. So what do we got? VLAN 15, 25, and 35. All right. So I believe IP route is not already enabled. Probably isn't on this switch. VLAN 15. Let's just see if we can move into interface VLAN. Okay, we're good. 10.0.1.1, 255.255.0. Shut. All right. Interface VLAN 15. We're good. IP address 10.0.15.1 255.255.0. Shut. So let's make VLAN. Let's make VLAN 25 now. Name it VLAN 5. Let's make VLAN 35 now. Name it base VLAN 5. The address 10.0.25.1 5.5.5.0. Got interface VLAN 35. IP address 10.0.35.1 5.5.5.0. Shut. Good. Right. Now we're going to assign deporty ports. All right. So we're going to now. All right. What are the physical? 01. So interface gigabit is at 0-1. What it is? Yep. All right. Switch port mode access VLAN 15. switchboard access VLAN. All right. Phase gigabit 1-1. Switchboard access VLAN 5. All right. Interface gigabit 2-1. Switchboard access VLAN 35. All right. All right. Interface 1 again. Let's exit. IP, DHCP, pool, VLAN 15, network 10.0.15.0.255.5.0, default router 10.0.15.1, IP, DHCP, pool, VLAN 25, network 10.0.25.0, 5.5.5.0, default 10.0.25.1, IP, DHCP, pool, VLAN 35, network 10.0.5.0, 25.5.5.0, default 10.0.35.1, exit, and then let's give it a do right, and let's do a do show. Let's do a do show run real quick. All right. Let's come over to our PCs now, and let's enable DHCP on our PCs to see if we got an address. Okay, and we did. So we got a dynamic address through DHCP on the layer 3 switch. So we're looking pretty good. And it's all, let's see if they all get correctly addressed. And look at that. Again, they're all getting correctly addressed. Oh, no. And boom, there we go. So we're looking good. Let's go to the desktop. Let's come over here. Let's see if we can ping 10.0.15.2. That is because probably they're not trumping over each other. Oh. This is a curious thing. It's funny because it's doing IP, it's doing layer 3 stuff, but it's not. I'm trying to think how I can weasel my way around this configuration. So I have it route between the trunk between the let's do this. It might work. Let's try it. Interface. Our interface is gigabit 0 dash 0 dash 0. I promise. Oh, 0 dash 1. Switch port, mode, trunk. Trunk. Interface, gigabit 1 dash 0. 1 dash 1. Switch port, mode, trunk. Interface, gigabit 2 dash 1. Switch port, mode, trunk. Do show trunk. I think I just broke it. Interface, gigabit 0 dash 1. Switch port, access 15. Interface, gigabit 1 dash 1. Switch port, access 5. Interface, gigabit 2 dash 1. Switch port, access 35. think I broke it. I did, didn't I? Huh. All right. Give this the interface. VLAN 15. Shut down. Right. One. Shut down. Betsy. Man, I really broke it, huh? I know. Switchport mode access. Switchport access. 15. Interface. Gigabit. Real F1. Switchport mode access. Switchport access VLAN 25. Interface. Gigabit. 2.0. Switchport mode access. Switchport access. VLAN 35. Alright. I think I fixed it back. There we go. I fixed it again after I broke it the first time. There we go. And there we go. So I can ping. So I can ping the router. It's just not going to allow me to ping anybody else. And that's because I don't have a trunking port set up on it. Oh, what's up? Oh, not bad. Yeah. Are you trying to route between a switch? Yeah, so what I'm going over is switch virtual interfaces and let me see if you're still in. Yeah, you're still here. Yeah, so what I was doing was I was I'm going over chapter 7, so chapter 17 in the OCG book. We're configuring routing between switch virtual interfaces. So what I was doing was I was just trying to see if I could trunk over those interfaces so I could pretty much communicate to each one. But what I was, I guess what I can't, it's because I can't create, I cannot have it not in a access port with it being a switch virtual, with it being a, I can't, if I take it, if I turn it into a trunk port, it won't work. So what I was trying to do, man, what was I trying to? How do I explain what I was trying to do? So what I was trying to do was can think of a way to create a virtual, I guess like a switch virtual trunk, which I have a VLAN. I have a native VLAN 1 that has an IP address. I wonder though, wonder if I do this. Wonder if I do this. Hang with me 1 second. Wonder if I do this. Do something funky. Funky. Wonder if I add a new port and make that a trunking port. Will I then be able to trunk, even though that's not connected to anything, would I be able to trunk over that? Oh, did I even save my configuration? I probably did it. Let me just see. I don't think I might have not saved that whole thing. All right, we're good. I thought I didn't save that whole thing. I would have been. All right, we're good. We're good. We're back to normal. We're back to normal, everybody. All is good. All right. All right. Now let's try this. All right. Everybody got their configured IP addresses through DHCP. Yeah, so I'm over here. So that's the router on the stick topology. I'm over here on, this is the switch virtual interface topology that we're doing, and then next would be the Ethernet port channel topology that we're going to be doing next. So let's think about this one. Interface. What was that new port that we just added? 3-1. Interface gigabit 3-1, and we're gonna say switch port trunk native VLAN 1. All right. Switch port mode trunk. All right, now let's see. Now let's see if just because I added this, even though it's like a dummy interface, if that will actually work. So let me do a, let's do a do show interface trunk. Now it's not showing anything. That's strange. That is strange. That is strange. Let me do a do show run again. Do show run. Hmm. So it's not even assigning. That didn't work. Copy. All right. I'm trying to just think like. Now, if I had another switch, I'd be able to do it though. I know I'd be able to do it if I had another switch, but can I do it with inside of a switch? That's what I'm trying to think of is how to. How do I make believe and trunk it without using another device? Interface. I'm still in this switch port. Thing is, it's already stating that it is a trunk. Security thing. Maybe it's not possible. It's not stating that in the book either. How to do it. let's move on to show interface status. Yeah, I know it's not connected to anything. Hmm. All right, we'll move on. We'll move on. But so that's so either way, we configured on we successfully configured the switch virtual interfaces. So I can ping we can ping our route, we can ping the switch, all right, which is our quote unquote router in this scenario. So you'll see the pings come back successfully, and they came back successfully right there. So we configured the switch virtual interfaces, but we just don't have, which I guess in a scenario you wouldn't want you wouldn't want traffic going between the VLANs and whatnot. But I was just trying to get it to do that. But yeah, so we got that scenario set up right there. All right. Now we'll move on to DSAWAN, which I'm curious to get into next. Okay. All right. VLAN routing with layer 3 switch routed ports. When layer 3 switches use SVI switch virtual interfaces, the physical interfaces on the switches act they act like they always have as layer 2 interfaces. That is the physical interfaces receive Ethernet frames. The switches learn the source MAC addresses of the frames, and the switches forwarding the frame. The switches forward the frames based on the destination MAC address to perform routing. And any Ethernet frame destined for any switch virtual interfaces, MAC addresses trigger the process of the layer 2 switching logic, resulting in the normal routing actions like stripping data link headers, making routing decisions, and so on. Alternatively, the layer 3 switch configuration makes a physical port act like a routing interface instead of a switching port. To do so, the switch configurations make the port a routed port. On a routed port, the switch does not perform layer 2 switching logic on that frame. Instead, the frame arrives in a routing port triggers the layer 3 routing logic instead, stripping off the incoming frame Ethernet data link and header and trailer, making layer 3 forwarding decisions by comparing the destination IP address in the IP routing table, adding the new Ethernet data link header and trailer to the packet, forwarding the packet encapsulated in the new frame. This third major section of the chapter examines interface, routed interface configured on the Cisco layer 3 switches, but with the particular goal in mind to also discuss layer 3 Ethernet channels. The exam topics do not mention routed interfaces specifically, but the exam topics do mention layer 3 Ethernet channels, meaning Ethernet layer 3 Ethernet channels. You might recall that in Chapter 10, RSTP and Ethernet channel configurations discussed layer 2 Ethernet channels like layer 2 Ethernet channels and layer 3 Ethernet channels also treat multiple links as one link. Unlike layer 2 Ethernet channels, however, layer 3 Ethernet channels treat the channels as a routed port instead of a switching port. So this section first looks at the routed ports on a Cisco layer 3 switch and then discusses the layer 3 Ethernet channel. Implementing routed interface on a switch. When a layer 3 switch needs a layer 3 switch interface is connected to a subnet and only one physical interface connects to that subnet, the network engineer can choose to use a routed port instead of a switch virtual interface. Conversely, when the layer 3 switch needs a layer 3 interface connected to the subnet, and many physical interfaces on the switch connected to that subnet, the switch virtual interface needs to be used. The switch virtual interface forwards traffic internally into the VLAN so that then the layer 2 logic can forward the frame out of any port in the VLAN. Routed ports cannot. Let me say that again. Switch virtual interfaces forwarded traffic internally into the VLAN so that then the layer 2 logic can forward the frame out of any port in the VLAN. Routed ports cannot. Okay. That's why, considering the design in the figure, which represent the same design in the other figure used in the switch virtual interface, in that design, the gray rectangle on the right represents the switch and its internals. On the right of the switch, at least 2 access ports sit on both VLANs 10 and 20. However, that figure shows a single link from a switch to the router. The switch can configure the port as an access port in a separate VLAN, as shown in VLAN 30. However, with only one switch port needed, the switch could configure that link as a router port, as shown. All right. Enabling the switch interface to be routed interface instead of a switching interface is simply just use the no switch port command on the physical interface. Okay. The Cisco switches capability of Cisco switches capable of being layer 3 switches use the default of switch port command to each switch physical interface. To think about the word switch port for the moment, with the term Cisco tells the switches to treat the port like it's a port on a switch. That is the layer 2 port on the switch. To make the port stop acting like a switch port and instead act like a routing port, use the no switch port command on the interface. Once the port is acting as a routed port, think of it like a routing interface. That is, configure the IP address on the physical port as implied in the figure. In the example shown as a completed configuration for the interface configured on the switch. Note that the design uses the exact same IP subnet as the example shown in the switch virtual interface configuration, but now the port connected to the subnet 10.1.30.0 has been converted to a routing port. All you have to do is add the no switch port command to the physical port and configure the IP address on this physical interface. All right. IP routing, yep. Interface VLAN 10, VLAN 20, and then we move into the actual physical ports. So it's a cool little topology. All right. For any topology with a point-to-point link between 2 devices that's doing routing, a routing interface works well. Shown in the figure, an example where to use switch virtual interfaces and where to use routing ports in a typical core distribution access design. In the design, the core 1 and core 2, and the distribution D11 through D14 switches perform layer 3 switching. All the other port and the links directly between the layer 3 switch can be routing ports for the VLANs, for which many interfaces access and trunks connected to the VLAN and switch virtual interfaces make sense because the switch virtual interfaces can send and receive traffic out multiple ports on the same switch, and design all ports on core 1 and core 2 will be routed ports, while the 4 distribution switch will have routed ports and some switch virtual interfaces. All right, implementing layer 3 Ethernet channels. So far, the section has started with routing interfaces can be used with a single point-to-point link between the pairs of the layer 3 switches, or between the layer 3 switches and routers. However, in most designs, the network engineer uses at least two links between each pair of the distribution and core switches as shown. So, okay, that's it. Right, so here we go. Add channel group mode. No switch port. All right, so we're gonna blast through this. All right. Well, let's do it. Do it to it. All right, let me get my handy schmandy little books. I got so many books. I got books for days. I got books for days. Ethernet channel. There we go. All right. All right. Let's get into it, man. So 0, 1, 2, 2, 3, 4, 5. Okay. All right. All right. So let's make a interface port channel 1. Okay. And now let's move into the let's see what we got. Interface main gigabit 0 dash 0 to 1. Oh. 0 dash 1 2 through 1. Yeah. All right, we're good. So then we're gonna say channel group channel group 1 mode on. Okay. Switch port. Oh, okay. I'm in the wrong configuration. Okay. That's that one. Let's exit. Now let's make another one. Interface port channel 2. All right. We're gonna say interface gigabit 2-1, 2, 3. All right. Interface range gigabit 2-1, 2, 3. Let me do it. Do show run. Do show run. Missed that one. So interface gigabit 0-1. I'm gonna say channel group. Channel group 1. Hold on. Okay. Do show run now. Do show. All right. They should be in the same channel group. Hopefully. And now let's exit there. Now let's interface gigabit 2-1 channel group 2. Hold on. Interface gigabit 3-1. Exit, and then one more. Interface port channel 3. Okay, and then interface 4-1 gigabit 4-1 channel group 3 on. All right, then the final interface is 5-1 interface gigabit 5-1. Okay, so do show run. Okay. So that should be that. Now let's make some VLANs. Exit. All right, VLAN. What do I got? VLAN 100 and VLAN 100. All right, VLAN 200 and 200. All right, VLAN 300. All right, that's it. Save this configuration real quick. All right, so now Let me do. Let's look at some stuff. So let's exit real quick. Show internet channel. We got group 1, group 2. Summary. All right, so we have our port channels, and they're good. All right, so our port channels are good. That's good. Okay. Just wanted to confirm that. Now let's move into interface, port channel 1. No switch port. Why does it say an invalid command? That's the command, damn you, man. You on your way home? Hello. We're streaming still. Hello. Nice. Not yet, sir. Set trunking mode interface. I always forget I have kids. Interface, event. I'm good. I don't even remember where I put it, honestly. Did I? Huh? No, I'm still streaming. What's up, Twitchers? What it do, what it do, what it do. Do. Ma. Yeah, there's nothing left though. Ma. Mhm. Guys, well, I gotta end the stream there. You guys have a good night. I gotta get ready to go to work, everybody. My wife's almost home, so again, I'll be on tomorrow, 5:30 Eastern Standard Time. I'll make sure I update my other stream information too, so you guys get the correct notifications for the times. Okay, so thank you guys again for all of you guys that joined me tonight. You guys are awesome people. I love every single one of you guys, and I will see you again tomorrow. All right, guys.